All right, so right here, we've got our graph. This is annual earnings in dollars of minimum wage workers, starting at the year 1950 and going to the year 2005. So where it says year zero, that's actually in reference to 1950. So year 5 would be 5 years after 1950, so 1955. So year 10 would be 1960, 10 years after 1950. And then 55 years after 1950 is the year 2005. Hence, this goes from 1950 to 2005. We can see all of those dots put over here. And the first thing I want to do is write a linear regression equation. Okay, so to get my regression equation, I'm actually just going to highlight this full table, Control C to copy. I'll come over here, Control V to paste, and there we go. I've got all my dots perfectly put in there, and my graph is already made. But what I want is the actual equation. Now, this data looks roughly linear, so we're going to make a linear equation. A linear equation is usually done by doing y equals mx plus b. Now, we are going to do something similar with this. Notice that over here, it's not using x and y, it's using x1 and y1. And that's because we could make multiple tables and the x's and y's from them might actually be different. Now, the equation we're about to write in is going to be y1 rather than an equals. We're going to have this squiggle mark. Now, m will stay the same, but rather than x, we want to use the x1. Now, when we do it that way, what we're doing is we're allowing Desmos to know where should you look for the information. Where do you look for the y data? Look in y1. Where do you look for the x data? Look in x1. And then plus b. And by creating these brand new variables, m and b, we're also letting Desmos know here are the numbers you have to play with. So move m and b up and down till you find the line that best matches this data. Okay, so let's see how it does that. So first I press the letter Y. Now, in order to get the subscript, that's the one that is lower and smaller, I press Shift and the minus key together, and now I've got a subscript. Next, I'm going to push forward, so I'm out of my subscript. In order to get that squiggle line, it is the symbol right next to your number 1. So to the left of the 1, but you press Shift and then that key. So if you just press, now, I don't know if any of you will have this issue.
Teachers, pardon
Sorry.
the interruption. We're just letting all the students know that the SheTech is leaving, the bus is leaving at 7:45. So if you're going to SheTech, make sure you're out to the bus by 7:45. Thank you.
Okay. If for some reason your Chromebook is set to a Spanish keyboard or the international keyboard, that button isn't going to quite work well. So if that's something that you've done to your keyboard, please switch it to the US standard English keyboard. Okay. If you are able to just press Shift and then that button and it shows up exactly like it showed up here, you're already on it. I believe you can tell on your Chromebooks by if you guys go down to that little black bar at the bottom of your screen, at some place it should just show US. If you see the US, it means you're on the US standard keyboard already, and you don't need to worry about anything I just said. Okay, just remember Shift, then and that symbol next to 1, and it'll give us that squiggle, which I should probably learn the name of. Next, we want M and then X. Now, once again, shift minus so that we can do the 1, MX. And notice it's already trying to find the line. But so far, all it's done is it's calculated what would be the value of M that would make it go through that the best. But we have no y-intercept, so it's just left that at 0. So now as I press B, it can now use both of those numbers and it makes an even better line. Okay. Notice right here, we got R, that's our correlation coefficient. Okay. I can plot my residuals. I don't see any clear pattern from those residuals. So this graph is probably a pretty good representation. And then down here, it says M equals and B equals. So it's already given me the numbers to use for my equation up here. So the linear regression equation is going to be y equals, rather than M, over there it says 210.69. So there's my M. Now I can put X plus B is a 2,586.67. So that's how I'm going to use Desmos to get the equation that we will use. And we just need to recognize that X is years since 1950 and Y is the annual income of a minimum wage worker. Okay, next one says, write the correlation coefficient R, describe how closely it fits. So R, and you can see it over here in Desmos, R equaled 0.98. Now, the closer it is to a 1 or a -1, the better the fit is. This is very close to a 1. For more information on in which ranges do you call it strong, moderate, or weak, or no correlation, go back and watch the 4.5 video in which I go through all of that. But I'm not going to repeat all of that information right now. Okay. But what I will say is that this is a positive number. It's very close to 1, which means this is a strong, positive correlation. Okay. All right. And we can also see that our line is following those data points fairly well. Now it wants us to use our equation to predict the annual earnings in 2020 and 1972 and compare it with our previous predictions. Oh, I think, so as far as 1972, comparing it to what that would have, I'm not so much worried about that as making sure you guys understand that this equation that we've written above, the purpose of it is for us to be able to make predictions. Okay, to use the information that we've found to predict how, to predict what annual income would be going forward in the future. Okay, so let's start with the 2020. Okay, now what I'm going to do, rather than y, I'm going to switch to my function notation. So I'm actually going to use f. Now, rather than of x, we're going to replace x with a number. Now, they said 2020. So 2020 would be 70 years after 1950, which is where our numbers started. So I'm going to do f of 70. And now I'm going to take that equation that we had above. So 210.69. And I'm just going to replace the X with a 70. Then we had plus B was 2,586.67. All right, now that I've got that equation written out, I'm just going to use Desmos to calculate it. So that would be 17,334.97. So about $17,000 per year is what we would expect the annual minimum wage income to be in the United States. Okay, so that is our prediction based off of data that only went up to 2005. Okay. So now that's our prediction for the future. And notice how we got both pieces of information. The 70 is representing the year 2020. That's our answer there represents our, represents the Y value, the earnings. Okay. Next one they wanted us to check was 1972. So that would be 22 years after 1950. So same thing. I take that equation that we found in step 1. I'm going to replace the X with a 22. Now, because I've already written this all out in Desmos, I'm just going to change the 70 to 22. Goes nice and fast. We get $7,221.85 as the annual income of a minimum wage worker in 1972. Okay, which if we take a look at our graph, so 22 would be about in there. And yeah, 7,300, that looks about right as to what we'd expect was probably common at that time. Okay, that's what you guys are going to be doing today on your own. Now notice the only thing I expect you to write are the same things that I've written. I don't expect you to redraw everything from this worksheet. Okay, that would just be a waste of your time. I want you focused in on using Desmos well, knowing how to use Desmos well. Okay, knowing how to quickly put your data into the table using the copy and paste like I showed you, or by pressing plus and then making a table and typing the numbers in. Making sure you can do the equation, okay, and get the answer. And then making sure that you can interpret different answers, making sure that you can use your equation to make predictions. That's the very point of these regressions, is making these predictions. Okay. Does anyone have any questions from what I have just shown you? Okay, so what the expectation is right now then. This is not a long worksheet. I expect everyone to submit it. So we already, in just that short time, and that was me taking a long time because I was explaining every single thing I was doing. So that only took us about 20 minutes to get through problem 1. And like I said, you can do it faster. I was explaining every step. There's just 3 more of these problems for you to complete. Okay, so even if you took as long as I did, you have enough time to do it. Write your work on a separate sheet of paper get this submitted into Canvas right here where it says linear regression worksheet. Okay. You just click start assignment and submit a picture of the paper where you've written down all of your work to receive credit for the work that you did today. Okay. This will not need to be group work today. So you all have permission now to go ahead and sign off and begin work on this worksheet. Okay. And when you're done, click submit. If you haven't finished 4.5 yet, please finish that. Okay. If you need help, you can stay on the Zoom meeting and I'll answer any questions that you have or help with any work that you need. Okay, but you guys can go ahead and start logging off. Okay, Mariah, Kayla, did you need any help? Okay, so what part did you need help with?